Okay, if we want to differentiate something, a function such as 3x squared e to the x cubed, that means I need to be in the position where I'm looking at the reverse of the chain rule. So let's just briefly talk about the chain rule. F of dash of, if I have f of g of x and I differentiate that, I want to differentiate f. You don't differentiate g, it stays the same. Then you times it by g dash. So the example, the classic one, is something like sine of 2x squared. If I differentiate f, it gives me cos. G of x stays the same, so it's 2x squared, and I times it by g dash. Okay, so 2x squared times 4x. Okay, so 4x comes out the front. So that's differentiating. Okay, so if you ever see that this function here, this function here, and this function here, this one differentiates to give me that one, that's the situation we're in with reverse chain rule. So x cubed does differentiate to give me 3x squared, so I'm dealing with e to the x cubed, okay, plus c. Now, if they're differentiated this, let's just differentiate d by dx, I get x cubed differentiates to give me 3x squared e to the x cubed. So that's perfect, okay? Now, let's change this a little bit. Let's make that into a 6, okay? So, if this is the question, and it says 6x squared, we now need to be a little bit more cautious, okay? We actually want that 6 to be a 3. So you make the 6 into a 3. You say it's 3 and put the 2 on the outside. 2 times 3 gives me 6, so I haven't changed the question. That means it's 2 times what this thing here would normally differentiate to be, integrate to be. So it's 2 times that, and that would give me the correct answer. So the answer, and some people are getting it, the answer is this one. It's this one up here, okay? Alright. Let's take another example, okay? Let's take the example of a half. So let's make this into a half. Let's rub that out. Okay. If this was a half, okay, we don't want it to be a half. We want it to be 3. So we'll just get rid of that there. So the goal is still to be able to integrate to give me the 3. However, it's not. So you need to create this half into a 3. So you get rid of, you take the half to the front. Okay. What times a half gives me 3? Okay. So we're saying this in here needs to be 3. This out here times 3 needs to give me a half. So not a half out here, but a 6th, because a 6th times the 3 that we want will give me what I actually want. So this needs to be a 3. See, if that was a half, 3 times 6, 1/6 is a half. So I need to carry a 1/6 down onto this one. Because obviously if I differentiated this, it would give me 1/6. 3 over 6 gives me a half. I'm done. So the 1/6 is whatever number multiplies to give me it. Okay. So let's try another example. Okay. Let's get rid of all of this first. It'll take me a second. I just needed a white pen to rub all of that out. Alright. Now I'll just make it a smaller size pen because otherwise it's going to be awkward. Right. So let's consider this. It's going to be 8x3 to the power of 4. It's going to be that. But I need a compensation factor. So 4 times, I'm expecting this to be 32x to the power of 7, x to the power of 8 minus 3 to the power of 4. So I want that 16 to be a 32. So I make it into a 32. 16 is now 32. I just need to put a half in front of here. Done. So then I put a half in front of here. And then I put a half in front of here and it'll give me the answer. So this here is what I want. plus c, of course. Okay. If that was not a 16, let's take another situation. Let's take it when it is a different number. We can make it a really frustrating number if we want it. Okay, let's make it, say, 7. Because 7 is not the nicest number, because it's not a factor of 32. Okay? So it's no longer a half, yeah? It's no longer a half. It's actually going to be something different. So, how do I make it 32? I want 32 there. So, what I want to say is that's not 32, so I make the 7 into 32. So, I need to, how did I do that? Well, I need to end up getting divide by 32 and times by 7 on the outside, because 32 divided by 32 would give me 1, and I'd still have that 7 there. I've just introduced this 32. Okay, and so now I've got a 7 32ths in front of it, 7 32ths, and those would cancel, and I'd end up getting what I want. So, the general big picture, if you have a thing that differentiates, this thing here, x to the power of 8 differentiates to give me x to the power of 7, or x cubed gives me x squared. It's reverse chain rule. Identify what your original function is, this big thing. Then you just need a multiplying factor. What do I need to multiply it by that would give me the answer I want?